All right, we're going to continue with section 14.8 in this video. We're on page 968, and we're going to do number 9, which is an exercise 9 through 17. Evaluate the integral by using the given transformation. So this is the double integral over r of y over x minus 3y dA, where r is the region bounded by the lines y equals 1, y equals 1/4 x, and x minus 3y equals e, and then they give us the transformation. So previously we did problems 18 and 20 something, 24. We did problems 18 and 24. And in those two problems, we were not given our transformation. We sketched our region and we figured out the transformation on our own, kind of from the equations that appeared in our region. So now in this problem, they give us a transformation, x equals something and y equals something. So what we'll do is we'll still sketch our region R and sketch our region S. But what I'm going to start doing is skipping the sketch for R and only doing the sketch for S, because sometimes the sketch for R is complicated and we don't need it. We just need the equations that come into play for R. So I'll sketch it for this one though. So we have the lines y equals 1, y equals 1/4 x, and x minus 3y equals e. Actually, they're all straight lines. Let's do this. So y equals 1. We'll put that right here. And then y equals 1/4 x. So say 1, 2, 3, 4. So that would be that line there. And the other line is x minus 3y equals e, which is the same as y equals x minus the quantity x minus e over 3. So our y-intercept is going to be about like right here, or actually no, about right here, closer to -1. And our slope I said was 1/3, so all right, so I see what our region is going to look like, but I don't think I have enough space to actually make it turn out properly. Let's try. All right, so we're going to go through that point right there and that point right there. Yes. Sorry, because I'm drawing with markers. It's just that little sliver of a triangle right there is our region. That's actually our region. You probably can't tell. It's just something that looks like this. If we were to zoom in on it, it'd be something that looks kind of like that. It's that region right there though, actually. But like I said, I'm going to stop sketching our region R. We just need our region S actually. All right, so now if we follow the steps that usually our first step is to define the transformation based upon, we've been defining based upon this region. But now this time they gave us a transformation. And the transformation they gave us though is not step 1. So step 1 normally is we let u and v be equal to something. So they gave us step 3, where step 3 is where you solve for x and y, and they gave us x equals 3u plus v, and that y equals u. And you'll see in this problem that I don't really need this sketch. So now we have that. So we want to do everything in our integral in terms of u and v now, instead of in terms of x and y. So we need to find bounds for u and v. So if we were trying to do things in terms of x and y, then we would look at this region and split it up, turn it into a couple of type 1 or type 2 regions. And then from there, we would evaluate our integral. But we're not doing that. We're doing a complete change of variables. So we're changing everything to u and v. So we're going to take those equations. What was this equation? This was 3 minus x minus 3y, equals e. X minus 3y equals e. So we're going to take these three equations and we're going to use those to find our bounds for u and v. So first I just use y equals 1/4 x. So this is separate from that. Y equals 1/4 x. We take that and we use it. Actually scrap that, don't underline that. I'm just trying to align things the same way I did in the previous two problems. So we take this in conjunction with that right there. So our y is the same as u. X is 3u plus v. So we get 3u plus v over 4. And then what we're trying to do is we're trying to isolate u or v, because we're trying to find bounds for u and v here. So this gives us, what do we get? We move this 3/4 u over to the left. So we get 1/4 u equals 1/4 v. So this actually gives us u equals v. Now from the next equation, x minus 3y equals e. X minus 3y equals e. We substitute our x in there and we get 3u plus v. 3u plus v minus 3y, but y is the same as u. So minus 3u equals e. And that just gives us v equals e. And then our last equation was y equals 1. So from that one we get y is the same as u, so we just get u equals 1. Alright, so we've gotten all the information we could out of here, but now we wrote it in terms of u and v, and we're going to now sketch that region. And sketching the region was step 2, if I'm not mistaken. Sketching the region S. Alright, so we're going to have u equals v, v equals e, and u equals 1. So and remember, this is the uv plane now. U equals 1. Well, u equals v. Let me do that first. So this is u equals v. And then u equals 1, and v equals e. So there's e right there. So this is the line v equals e. And then u equals 1. We'll say it's right here. So this is u equals 1. All right. And make sure you're careful, because we see this looks like a closed region, that looks like a closed region, but that's just because of our coordinate axes. This actually is not our region, nor is that. This is the only closed region that's closed by those three curves. So that's our region S right there. Now we look at this region S and see that it's both a type 1 and a type 2 region. So you do it whichever way you prefer. I'm going to do it as a type 1 region. So I'm going to go from function to function in the vertical direction. So I'm going from v equals u up to v equals e, function to function that way. and then constant to constant, I'm going from u equals 1 up to, this is u equals v right here. So that tells us that u is also equal to e right there, because this is right here is the point e comma e. So our region is that little region right there. And this was step 2. I'm going to try to remember to label these steps that are used in the textbook. So that's step 2 right there. And step 4, because we already noticed we didn't need 1 at all. And so they gave us 3, and then we need to do 2. And now we're going to do step 4, which is our Jacobian. So step 4 is the Jacobian. So we're going to take the partial of x with respect to u, and we're just going to get 3. The partial of x with respect to v, we're going to get 1. Then the partial of y with respect to u, we're going to get 1. And the partial of y with respect to v, we're going to get 0. So our Jacobian is just 0 minus 1. We get negative 1 for our Jacobian. So now we can go ahead and set up our integral. So part 5. So now we have the double integral, and our region here is u varies from 1 to e. So 1 up to e. And v varies from u up to e. And our integrand, so we go back to our original problem, we have y over x minus 3y. So what we're going to do is we're going to use what we have here. So y over x minus 3y is going to be u over this minus 3 times that. So that minus 3 times that is just v. So we're going to end up just u over v. And then don't forget our Jacobian, which here is not a big issue if we forget, because the absolute value of -1 is just 1. But let's put it in there so we don't forget in general. And then these were v's, so that's dv. And those were u's, so that's du. And then you just evaluate that integral. All right, so I'll stop this video here, and then the next video I'll do another example from section 14.8.